The Robinson annulation reaction is a combination of a Michael addition with an aldol condensation. The Michael addition takes place first with some sort of dicarbonyl compound being converted with a strong base into an enolate. The enolate then does the Michael addition 1,4 conjugated addition reaction to a molecule like this, some sort of conjugated system. And that gives us this product right here. This is the conjugated system is right here, and we've added it, created this bond right here, and added it to the alpha carbon. Once this product has been formed, we then do the aldol condensation reaction. So these 4 carbons end up in these positions right here. So our carbon-oxygen double bond is right there. The aldol reaction creates this bond, and since it's a condensation reaction, we end up with a carbon-carbon double bond. If you'd like to see the mechanism of this reaction, I am going to attempt to draw it in the space below. It's a pretty long reaction. Hopefully I don't lose any carbon atoms or forget any steps along the way. The first part of the reaction is forming the enolate with our strong base, hydroxide. We're just going to grab that hydrogen and put a lone pair of electrons on the alpha carbon in between the 2 carbon-oxygen double bonds. This is our Michael donor, or the nucleophile, that's being used in the Michael addition part of the reaction. The nucleophile enolate is going to attack carbon number 1 of the 4 atom conjugated system. We're going to shift all of the bonds around. This is the part where I have to be careful to make sure that I don't lose any of my carbons. So I'm creating a bond between this carbon and the first carbon of the conjugated system. That carbon is part of a total of a 1, 2, 3, 4 carbon chain, 1, 2, 3, 4 carbon chain, carbon-oxygen double bond right here, except for, oh, it's not a double bond anymore. It's a single bond. And I'm going to put some numbers on these carbons to help us keep track of them. 1, 2, 3, 4. The next step of the reaction, we formed a water molecule right here when we removed the alpha hydrogen, and that water molecule is just going to be used to protonate the oxygen, the negatively charged oxygen. And I've got to try to write small so that I'll have enough room to fit everything in. 1, 2, double bond to 3, 4. Double bond to 3, 4, OH. Make sure I didn't lose any carbons. 1, 2, 3, 4. This is now, we've finished the Michael addition part. We are now ready for the aldol condensation part of the reaction. We're going to use hydroxide ion again. We just created some hydroxide ion right here. The hydroxide ion, oh, actually, you know what I have forgot to do? I forgot to tautomerize my enol. That enol right there. I almost forgot a step. 1, 2, 3, 4, double bond to an oxygen. 1, 2, 3, 4. Okay, now we're ready for the aldol condensation. So we're going to take that hydroxide and we're going to grab one of the hydrogen atoms off of carbon number 4. It's going to selectively go after these hydrogen atoms in that 4th carbon position, because if it instead took a hydrogen atom from this place, it would not be able to form the correct sized ring. If you can recall back from when you first learned about aldol condensation reactions that could be used to form a ring, one of the things that you learned was that the ring would only be formed if it was like a 5-membered ring or a 6-membered ring. Those are the most favorable sizes. 1, 2, 3, 4. And now our enolate is going to attack either one of the carbonyl carbons. Doesn't matter because they are the same. I just randomly switched colors there. Open up the carbon-oxygen double bond. We are now doing the aldol addition part of this reaction. And so one more time, I need to be really careful about my bonds, making sure that I have the right number of carbon atoms. I'm going to begin by drawing this oxygen down here. That's carbon-oxygen bond that has opened up to become a single bond. And then I also have 1, 2, 3, 4 carbons that I need to fit out here and form a connection like that. 1, 2, 3, 4 connection. I'm going to put these numbers back. 1, 2, 3, 4, 1, 2, 3, 4, just to make sure that I know exactly where the carbon-oxygen double bond goes. Now, we're getting close to the end, but we still have a bit more to go. So we're going to finish up the aldol addition reaction by protonating our oxygen, our O-, like that. And I got to give myself a little bit more room for my carbonyl group. I've got 2 6-membered rings that are fused together and an OH. And the last thing that we need to do in this reaction is the aldol condensation. So I'm going to turn my OH around to make room for me to draw in the alpha hydrogen. We're going to use the hydroxide that was just created right here, OH-. We're going to grab one of those alpha hydrogens. We're going to move the carbon-hydrogen electrons in to make a carbon-carbon double bond and get rid of this OH as a leaving group, and we are finally done with this mechanism. None of the steps in this mechanism are extremely difficult. It's just really tedious, and there's a lot of places where you could make a mistake in terms of like adding an extra carbon or losing a carbon or connecting things in the wrong order. So you just want to be really careful when you're drawing this reaction.